electrical panel cannot generally be used as a raceway or a J-box. NEC Section 312.6 states that raceways shall not be used as enclosures for equipment, except as permitted in 312.5. NEC Section 312.5c states that panels designed for the purpose shall be permitted to be used as raceways. NEC Section 314.28 states that junction boxes, pull boxes, device boxes, and fittings shall be used only with covers installed. Regarding the raceway exception, NEC Section 312.5c permits panels designed for the purpose to be used as raceways. However, this exception only applies to panels that are specifically listed for use as raceways. Regarding the J-box exception, NEC Section 314.28 does not explicitly prohibit the use of panels as J-boxes. However, the NEC requires J-boxes to be covered. Since panels cannot be covered, they cannot be used as J-boxes. Therefore, you can use a panel as a raceway only if the panel is specifically listed as a raceway. Otherwise, a panel cannot be used as a raceway. There are additional considerations, as using a panel as a raceway or J-box can compromise its integrity and safety. It can make it difficult to access wires and devices in the future. It can violate electrical codes and insurance requirements. The best practice is to use proper raceways and J-boxes to ensure electrical safety and code compliance. Electrical raceways are enclosed channels designed to hold and protect electrical wires and cables. They provide a physical barrier against damage, moisture, and other environmental factors, ensuring the safe and reliable operation of electrical systems. There are several types of electrical raceways, each suited for specific applications. These include conduits, which are rigid or flexible tubes made of metal or plastic, cable trays, which are open support structures for multiple cables, and wireways, which are enclosed troughs with hinged or removable covers. The choice of raceway depends on factors such as the number and size of wires, the environment, and the applicable codes and standards. Electrical junction boxes, often called J-boxes, are enclosures that protect electrical connections. They serve as a central point where multiple wires or cables are joined, providing a safe and organized way to distribute power. Junction boxes are typically made of metal or plastic and come in various sizes and shapes to accommodate different wiring configurations. They are essential for preventing electrical hazards such as short circuits and fires. Junction boxes must be installed according to electrical codes and standards, ensuring that all connections are properly insulated and protected. Electrical panels, also known as distribution boards or breaker panels, are a critical component of electrical systems. They receive power from the utility company and distribute it to various circuits within a building. The panel houses circuit breakers or fuses that protect each circuit from overloads and short circuits. Electrical panels are designed to be accessible for maintenance and repairs, but they must also be secure to prevent unauthorized access. Proper labeling of circuits within the panel is essential for easy identification and troubleshooting. The National Electrical Code, or NEC, is a set of standards and guidelines for the safe installation of electrical wiring and equipment in the United States. It is developed and updated by the National Fire Protection Association, or NFPA, and is widely adopted by state and local jurisdictions. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring electrical safety and preventing hazards such as fires and electric shocks. The NEC is updated every 3 years to reflect advancement in technology and changes in industry practices. Electrical codes and standards are essential for ensuring the safety and reliability of electrical systems. These codes provide detailed requirements for the installation, maintenance, and operation of electrical equipment, helping to prevent hazards such as fires, electric shocks, and equipment failures. Compliance with electrical codes is not only a legal requirement, but also a best practice for protecting people and property. Regular inspections and audits can help identify potential hazards and ensure that electrical systems are up to code. Electrical safety is paramount in any electrical installation or maintenance activity. It involves taking precautions to prevent electrical shocks, burns, and other injuries. Some essential safety measures include using personal protective equipment such as gloves and safety glasses, de-energizing circuits before working on them, and following lockout/tagout procedures to prevent accidental energization. Regular training and education are also crucial for ensuring that workers are aware of the hazards associated with electricity and how to mitigate them. Grounding is a critical aspect of electrical safety. It involves creating a low-resistance path for electrical current to flow back to the source in the event of a fault. Grounding helps to protect people and equipment from electrical shocks and damage by providing a safe path for fault current to flow. The NEC specifies detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding metal enclosures. Proper grounding is essential for ensuring the safe and reliable operation of electrical systems. Overcurrent protection is another essential aspect of electrical safety. It involves using devices such as circuit breakers and fuses to protect electrical circuits from overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. The NEC specifies detailed requirements for overcurrent protection, including the size and type of overcurrent protection devices, the location of overcurrent protection devices, and the methods for coordinating overcurrent protection devices. Proper overcurrent protection is essential for ensuring the safe and reliable operation of electrical systems. Wiring methods refer to the techniques and materials used to install electrical conductors. The NEC specifies various wiring methods, each suited for specific applications. These include conduit wiring, cable wiring, and open wiring. Conduit wiring involves enclosing conductors in rigid or flexible metal or plastic tubes, providing physical protection and preventing damage. Cable wiring involves using insulated cables that are run through walls, floors, or ceilings. Open wiring involves attaching conductors to insulators that are mounted on walls or ceilings. The choice of wiring method depends on factors such as the environment, the type of building, and the applicable codes and standards. Electrical panels are typically constructed of metal such as steel or aluminum to provide durability and protection for the internal components. The enclosure is designed to be dust-tight and water-resistant, protecting the electrical connections from environmental factors. The front panel of the enclosure is typically hinged and can be opened for access to the circuit breakers or fuses. The panel also includes knockouts for installing conduits or cables to connect to the electrical system. The size of the electrical panel depends on the number of circuits it needs to accommodate. The circuit breakers or fuses are the overcurrent protection devices that protect each circuit from overloads and short circuits. Circuit breakers are resettable devices that trip when the current exceeds a safe level, while fuses are one-time devices that must be replaced after they blow. The circuit breakers or fuses are arranged in rows or columns within the electrical panel, and each is labeled to indicate the circuit it protects. The electrical panel also includes a main breaker or fuse that protects the entire panel from overloads and short circuits. The main breaker or fuse is typically located at the top of the panel and is sized to match the capacity of the electrical service. The electrical panel is connected to the electrical service through a set of wires called the service entrance conductors. The service entrance conductors are typically large gauge wires that can handle the entire load of the electrical system. The service entrance conductors are connected to the main breaker or fuse in the electrical panel. The electrical panel also includes a grounding system that provides a path for fault current to flow back to the source in the event of a fault. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the grounding electrode to the electrical panel. The grounding system is essential for protecting people and equipment from electrical shocks and damage. The installation of electrical panels must comply with the National Electrical Code, or NEC, and other applicable codes and standards. The NEC specifies detailed requirements for the installation of electrical panels, including the location of the panel, the size of the service entrance conductors, the type of overcurrent protection devices, and the grounding system. Proper installation of electrical panels is essential for ensuring the safe and reliable operation of the electrical system. When selecting an electrical panel, it is essential to consider the size of the electrical service, the number of circuits required, and the type of overcurrent protection devices needed. The electrical panel should be sized to match the capacity of the electrical service. The number of circuits required will depend on the number of appliances, lights, and other electrical loads in the building. The type of overcurrent protection devices needed will depend on the type of electrical loads and the applicable codes and standards. It is also essential to consider the quality and reliability of the electrical panel. Choose a panel from a reputable manufacturer that meets or exceeds industry standards. Proper maintenance of electrical panels is essential for ensuring their safe and reliable operation. Regular inspection should be conducted to check for loose connections, corroded wires, and damaged components. The circuit breakers or fuses should be tested periodically to ensure that they are functioning properly. The electrical panel should be kept clean and free of debris. Any repairs or replacement should be performed by a qualified electrician. The NEC Section 312.5 provides specific guidelines regarding enclosures for switches or overcurrent devices, and it details when and how enclosures, including panels, can be used for conductors. Section 312.5c particularly addresses situations where panels are designed for use as raceways. In these instances, the panels must be specifically listed for such use, ensuring they meet the necessary safety and performance standards. The NEC in Section 314.28 outlines the requirements for junction boxes, pull boxes, and device boxes, emphasizing the need for covers to protect the electrical connections. While this section does not explicitly forbid the use of panels as junction boxes, the requirement for covers essentially eliminates panels as a viable option since they are not designed to be covered in the manner prescribed for junction boxes. When using a panel as a raceway, it is crucial to adhere to the manufacturer's instructions and the applicable electrical codes. This includes ensuring that the panel is properly grounded, that the conductors are properly supported, and that the panel is not overloaded. It is also important to consider the environmental conditions in which the panel will be used, as this may affect the type of panel and the wiring methods that are appropriate. Understanding the NEC guidelines and the manufacturer's instructions is paramount when using a panel as a raceway. This ensures the safety and reliability of the electrical system and minimizes the risk of electrical hazards. Using an electrical panel as a raceway or junction box without proper consideration and adherence to the NEC can result in several safety hazards. Firstly, it can compromise the integrity and safety of the panel, potentially leading to electrical shorts, fires, or equipment failures. Secondly, it can make it difficult to access wires and devices in the future, hindering maintenance and troubleshooting efforts. Lastly, it can violate electrical codes and insurance requirements, resulting in fines, penalties, or denial of coverage in the event of an incident. To ensure electrical safety and code compliance, it is essential to use proper raceways and junction boxes instead of relying on electrical panels for these purposes. Raceways and junction boxes are specifically designed to protect electrical connections and provide a safe and organized wiring system. They are available in various sizes and configurations to accommodate different wiring needs. The use of proper raceways and junction boxes is not only a code requirement but also a best practice for ensuring the long-term reliability and safety of electrical systems. Electrical codes and standards are not static. They are updated periodically to reflect advancements in technology, changes in industry practices, and lessons learned from past incidents. Staying up to date on the latest codes and standards is crucial for ensuring that electrical installations and maintenance activities are performed safely and in compliance with applicable regulations. Professional electricians and electrical contractors typically receive ongoing training and education to stay abreast of the latest codes and standards. In addition to the NEC, there may be other local or regional codes and standards that apply to electrical installations. It is essential to check with the local authorities to determine which codes and standards are in effect in a particular jurisdiction. Compliance with all applicable codes and standards is essential for ensuring the safety and reliability of electrical systems. When working with electrical systems, it is essential to follow lockout/tagout procedures to prevent accidental energization. Lockout/tagout procedures involve de-energizing the circuit, disconnecting the power source, and attaching a lock and tag to the disconnect switch or circuit breaker to prevent it from being turned on accidentally. Lockout/tagout procedures are designed to protect workers from electrical shocks and other hazards. It is essential to follow lockout/tagout procedures whenever working on electrical equipment, regardless of whether the equipment is energized or de-energized. Electrical safety audits are a valuable tool for identifying potential hazards and ensuring that electrical systems are up to code. Electrical safety audits involve a thorough inspection of electrical systems, including wiring, equipment, and grounding systems. The audit is typically performed by a qualified electrician or electrical inspector. The audit report will identify any deficiencies and recommend corrective actions. Regular electrical safety audits can help prevent electrical hazards and ensure the safe and reliable operation of electrical systems. The use of appropriate personal protective equipment, or PPE, is essential for protecting workers from electrical hazards. PPE may include safety glasses, gloves, insulated tools, and arc-rated clothing. The type of PPE needed will depend on the specific task being performed and the potential hazards involved. It is essential to inspect PPE before each use to ensure that it is in good condition and functioning properly. Damaged or defective PPE should be replaced immediately. Training and education are essential for ensuring that workers are aware of the hazards associated with electricity and how to mitigate them. Training should cover topics such as electrical safety, grounding, overcurrent protection, wiring methods, and lockout/tagout procedures. Training should be provided by a qualified instructor and should be tailored to the specific needs of the workers. Regular refresher training is essential for keeping workers up to date on the latest safety practices. The electrical system in a building is a complex network of wires, equipment, and devices that work together to provide power for lighting, appliances, and other electrical loads. The electrical system typically consists of a service entrance, an electrical panel, branch circuits, and grounding system. The service entrance is the point where the electrical service enters the building. The electrical panel is the central distribution point for the electrical system. Branch circuits are the individual circuits that supply power to various electrical loads. The grounding system provides a path for fault current to flow back to the source in the event of a fault. Understanding the basic components of the electrical system is essential for troubleshooting problems and performing maintenance activities. Electrical troubleshooting involves identifying and resolving problems with electrical systems. Troubleshooting may involve using electrical testing equipment, such as multimeters and circuit tracers, to diagnose problems. It is essential to follow safety precautions when troubleshooting electrical systems to prevent electrical shocks and other hazards. If you are not qualified to troubleshoot electrical systems, it is best to call a qualified electrician. Electrical maintenance involves performing regular inspections and repairs to keep electrical systems in good working order. Maintenance may involve tightening connections, replacing worn or damaged components, and testing overcurrent protection devices. Regular maintenance can help prevent electrical hazards and ensure the safe and reliable operation of electrical systems. If you are not qualified to perform electrical maintenance, it is best to call a qualified electrician. In electrical installations, the correct sizing of conductors is critical for ensuring safety and efficiency. The ampacity, or current carrying capacity, of a conductor must be sufficient to handle the expected load. The National Electrical Code, specifically Article 310.15, provides guidelines for determining the allowable ampacity of conductors based on factors such as the conductor material, insulation type, ambient temperature, and the number of conductors in a raceway or cable. Using undersized conductors can lead to overheating, insulation damage, and even fires. Conversely, using excessively large conductors can be unnecessarily expensive. Proper conductor sizing is a fundamental aspect of electrical design and installation. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits and equipment from damage caused by overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a safe level, preventing overheating and potential fires. Circuit breakers are resettable devices that can be manually or automatically reset after a fault is cleared, while fuses are one-time devices that must be replaced after they blow. The selection of appropriate overcurrent protection devices is based on the ampacity of the circuit conductors and the characteristics of the connected load. The National Electrical Code provides detailed requirements for overcurrent protection in Article 240. Grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, allowing overcurrent protection devices to quickly clear the fault. Bonding ensures that all metal parts of an electrical system are electrically connected, minimizing the potential for voltage differences that could cause electric shock. The National Electrical Code, Article 250, provides comprehensive requirements for grounding and bonding electrical systems. Proper grounding and bonding are essential for protecting people and equipment from electrical hazards. Electrical enclosures, such as panels, junction boxes, and device boxes, provide protection for electrical components and connections. Enclosures are designed to prevent accidental contact with energized parts and to protect against environmental factors such as moisture, dust, and physical damage. The National Electrical Code, Article 314, provides requirements for the construction and installation of electrical enclosures. Enclosures must be properly sized to accommodate the conductors and devices they contain, and they must be securely mounted to prevent movement or vibration. Electrical raceways, such as conduits, tubing, and cable trays, provide a protected pathway for electrical conductors. Raceways protect conductors from physical damage, moisture, and other environmental factors. The National Electrical Code, Article 348, provides requirements for the construction and installation of electrical raceways. Raceways must be properly sized to accommodate the conductors they contain, and they must be securely supported to prevent sagging or damage. Wiring methods refer to the techniques and materials used to install electrical conductors. The National Electrical Code recognizes a variety of wiring methods, each suited for specific applications. Common wiring methods include conduit wiring, cable wiring, and surface wiring. The selection of an appropriate wiring method depends on factors such as the type of building, the environmental conditions, and the applicable codes and standards. Electrical testing and measurement are essential for ensuring the safety and reliability of electrical systems. Electrical testing involves using specialized equipment to verify the proper functioning of electrical components and circuits. Common electrical tests include voltage measurements, current measurements, resistance measurements, and insulation resistance tests. Electrical measurement involves using instruments such as multimeters, clamp-on ammeters, and insulation testers to quantify electrical parameters. The results of electrical testing and measurement can be used to identify potential problems and to verify that electrical systems are operating within safe and acceptable limits. The NEC is not a design manual, but rather a set of minimum safety standards. It is essential to consult with a qualified electrical engineer or designer to ensure that electrical systems are designed and installed in accordance with all applicable codes and standards. The NEC is updated every 3 years to reflect advancements in technology and changes in industry practices. It is essential to stay up to date on the latest version of the NEC to ensure that electrical installations are in compliance with current regulations. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and other retailers. The NEC is also available for online viewing through various subscription services. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Failure to comply with the NEC can result in fines, penalties, and even criminal charges. Proper electrical safety practices are essential for protecting people and property from electrical hazards. Always to energize circuits before working on them. Use appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated tools. Follow lockout/tagout procedures to prevent accidental energization. If you are not qualified to perform electrical work, it is best to call a qualified electrician. Remember that electricity can be dangerous, and it is essential to take all necessary precautions to prevent accidents. The knowledge presented here is a general overview. It does not substitute consultation with a qualified expert, engineer, electrical contractor, or electrician.